students, how are you all? Welcome to online classes. In the last video we have discussed about light spectrum and how to calculate the wave number, lambda maximum, lambda minimum for different lines in different atoms we have completed. In this session I am going to discuss Bohr's atomic model. Bohr's atomic model. So it explains the electronic structure of atom. This was given by Niels Bohr. So it gives electronic structure of atom. Structure of an atom. Important postulates of Bohr's atomic model. Few points are required for us. So this was given by Niels Bohr. You know already. Electron revolve around the nucleus in a fixed orbit with fixed radius and velocity called orbits. So these are indicated by n. N may be 1, 2, 3, 4, 5. Otherwise indicated with alphabets K, L, M, N, O, P, like that. Now, so it was given by Niels Bohr in the year of 1913. First one, electron revolve around the nucleus in a circular path with fixed radius and velocity called orbits. So these are indicated by n, that may be 1, 2, 3, 4, etc. or alphabets. Also we can K, L, M, N, so on. Whatever it is, you can indicate like this. So this is nucleus. It is electron revolve around the nucleus in a circular path. This path is called orbit. So first part, second part, third part, fourth part, like that. Totally 1, 2, 3, 4, 5, so on. Infinite number of orbits are possible. Now, after this. So if electron revolve around in a fixed path, not jumping from one to another, energy neither absorbed nor released. Such orbits are named as stationary orbits. Energy neither released nor absorbed when electron revolve in a fixed path. Electron revolve around nucleus in a fixed path. These are called stationary orbits. It means it is revolving in this only, but not jumping from one to another. Next. Electron jumps from one energy level to the another energy level. So the energy may be absorbed or emitted. For example, if you are coming from first floor to the fourth floor, energy is required, nothing but absorbed. If you come from fourth to the first floor, obviously energy is released, you can come very freely, right? Similarly here also, when electron jumps from higher energy level to lower energy level, energy is emitted. Energy is emitted. So when electron jumps from lower energy level to higher energy level, energy is absorbed. So the energy change, whether it is absorbed or released, it will be in a discontinuous manner. The energy change in a discontinuous manner, but not in a continuous manner. Now this is nucleus, first orbit, second orbit. When electron jumps from lower to higher, first orbit to second orbit, energy absorbed. Higher to lower it is, 2 to 1, energy released, right? Energy released. Next, the energy difference, the difference between the energy of two levels. Now, the difference of energy between two levels, the difference of energy in two levels taken as delta E, indicated as E2 minus E1. It is higher energy level, this is lower energy level. Energy of higher energy level, energy of lower energy level, right? Then delta E, energy is directly proportional to frequency. Then E2 minus E1 equal to h nu, where nu equal to E2 minus E1 by h is. So we are studying a Bohr's model, which is a Bohr's frequency. This is called Bohr's frequency rules. Okay. Next one, angular momentum of electron, especially of a stationary orbit, can be expressed in the following. Next, angular momentum of an electron in stationary orbit expressed as follows. So how do write the angular momentum of electron? So now that is first one. Angular momentum of electron is equal to momentum of electron equal to I into omega, where I equal to moment of inertia, it is moment of inertia, omega equal to angular velocity, So moment of inertia is mr square. This is equal to mr square. This is equal to v by r. This is equal to v by r. Angular momentum of electron is equal to finally mr square into v by r. So r cancel, finally mvr. Angular momentum of an electron equal to mvr. Linear momentum equal to mv, if you wanted to write. Linear momentum of electron is equal to m into v. Angular momentum inertia, by this I have done. The angular momentum of an electron is an integral multiple of h by 2 pi. Right, next one. The angular momentum of an electron is an integral multiple of h by 2 pi. It means it's a fixed value. Integral multiple means mvr is equal to, angular momentum is equal to integral multiple of h by 2 pi. That's what nh by 2 pi is. This is nh by 2 pi, where n equal to 1, 2, 3, so on like that. If n equal to 1, then 1 by 2 into h by pi. n equal to 2 by 2 into h by pi. n equal to 3 by 2 into h by pi. Important, remember. Next, this is about angular momentum. That's why, so only contains fixed orbits are allowed. Now, these are the postulates of which one? Bohr's theory. Next one is after this. What are the advantages of Bohr's theory and disadvantages of Bohr's theory? Advantages of Bohr's theory. It means, so what he explained, what did he explain by this theory? First one, he explained line spectrum of atoms like hydrogens. Second one is radius of orbit. Next, energy of an electron. Next, velocity of an electron in a particular orbit. So these are the points he explained clearly. So line spectrum, velocity, energy, radius, and he explained stationary orbits. So about stationary orbits also he explained. Next, disadvantages or limitations of Bohr's model. So limitations or disadvantages of Bohr's model. This theory fails to explain spectrum of multi-electron atoms. It means it is only applicable for atoms which are resemblance with that of hydrogen, but not with the 2 electrons, 3 electrons, 4 electrons containing atoms. So next point, Zeeman effect. He didn't explain Zeeman effect. Zeeman effect means splitting of spectral lines we observed. Those lines will be splitted in presence of magnetic field and electric field into different lines. That nature is not explained by Bohr's. Splitting of spectral lines in magnetic field. Next, we didn't explain about Stark effect. Splitting of spectral line in electric field. Next, it does not explain the formation of things. It does not explain the formation of chemical bond. This is also one drawback. Next, It does not explain the quantization of angular momentum. It does not explain the quantization of angular momentum of an electron. So these are the points he didn't explain, by which theory, that is Bohr's atomic model. Now, so he explained about the radius, energy, velocity. We discussed already we have discussed the spectrum and the radius of orbit, energy of electron, and next one, velocity of electron. We will discuss one by one. Now, first one is radius of an orbit. There are number of orbits, infinite number of orbits possible. So I discussed the radius of nth orbit, where n may be 1, 2, 3, 4, 5, 6, etc. So by that formula, we can easily measure the radius of first, second, third, fourth, fifth, whatever that may be, infinite orbit also, we can find the radius of orbit. Now, radius of an orbit, right? So this is that to nth orbital. Orbit number is n, right? Nth orbit. You know, this is nucleus. Electron revolve around the nucleus in a circular path. While revolving electron, there is a chance to attract the proton in the nucleus with the electron. Then electron fall into the nucleus. Otherwise, if opposes extra force by the nucleus, then electron fall outside. That's why the opposing force is equal to attracting force. The attracting force between the electron and nucleus is centripetal force. Opposing is centrifugal force. These forces must be same. Then only electron revolve around the nucleus in a particular fixed orbit. Now, so this is attractive force. This is called centripetal force. Centripetal force. This is equal to minus kZe square by r square. Just kZe square by r square. And another force also opposing this. So this force is called centrifugal force. Centrifugal force. So this is equal to mv square by r. mv square by r. To revolve electron around a fixed orbit, so this force and this force must be same, then only it will be revolved in a fixed orbit. Now, centrifugal force is equal to centripetal force. Centripetal force. mv square by r is equal to kZe square by r square. Students, r and square will be cancelled. Then mv square equal to kZe square, where k is a proportionality constant, that is equal to 1 by 4 pi epsilon naught, where epsilon equal to permittivity factor. No need for us. So these are all terms. Next one. According to angular momentum, angular momentum of electron, angular momentum, mvr equal to nh by 2 pi, where v equal to nh by 2 pi mr, right? V square, I need a square, that's why v square I am calculating, squaring on both sides, then that is equal to n square h square by 2 to the 4 pi square m square r square, right? Now, this is taken as 1, this is taken as 2, this will be taken as 2. So 2 will be substituted in 1, 2 in 1. Then what we will do? m v square is n square h square by 4 pi square m square r square is equal to k z e squares. Right? So this is what we are doing. Here r left, k z is square by r, and here z is square by r square and r will be cancelled. Then I am separating this term. M square and m will be cancelled. Then r equal to r shifted here, kz is square. N square h square by 4 pi square m k z e square. This is the radius of orbit in nth orbit. Radius of which one? Nth orbit. Now, n value they will provide in the question, whether it is the first orbit, second orbit, third orbit, fourth orbit, whatever. So, n value will be changed. H value equal to 6.626 into 10 to the power of minus 34 joules seconds. So, joule equal to kg meter square second minus 2. So, this will be taken as 6.626 into 10 to the power of minus 34. So, kg meter square second minus 2 into seconds. Joule means kg meter square second minus 2 seconds. Next, pi value you know 3.14. Next, mass of electron, this is 9.109 into 10 to the power of minus 31 kgs. So Z equal to atomic numbers. So this will be given in the question for different atoms. You can find the radius. Radius of third orbit in lithium. N equal to 3. Lithium atomic number will be 3. Like that you can find. Next. So E equal to charge of electron, that is of an electron. 1.6099 into 10 to the power of minus 19 coulombs. And K equal to proportionality constant, that is the value will be 9.109 into the value of 10 to the power of 9 kg meter second, 10 to the power of 9 Newton meter square per coulomb square it is. Newton meter square per coulomb square it is. So 10 to the power of 9 kg meter second minus 2. So 9.10 to the power of 9 kg meter second minus 2 into meter square by coulomb square. Newton is nothing but this. Substitute all the terms in the above expression, then you will get the final expression. That is, finally, if you substitute it, then you will get an expression. So, Rn is equal to 52.9 into 10 to the power of minus 12 meters into n square will not be cancelled and z will not be cancelled. That will be decided on the given data in the exam. So by n square by z. This is the formula for us. So 52.9 10 to the power of minus 12 meters means picometers into n square by z. So 0.529 angstrom units into n square by z. In angstrom units I have taken students. Right? This is the formula. R value is directly proportional to n. R value inversely proportional to z. So n value increases, radius also increases. As n value increases, radius also increases. It means it is the first order, this is the radius, it is the second order, third order, fourth order, like this. Understood? Number of orbits increases, radius of atom also increases. So this is the formula for us. A simple question, possible questions on this data is, calculate the radius of third orbit of lithium atom. Question. Calculate the radius of third orbit of lithium plus 2 plus 3, whatever it is, lithium is. So now the formula is Rn equal to 52.9 picometers into n square by z, where n equal to third orbit 3, z equal to atomic number of lithium, that is equal to 3. Substitute all values. It is R3, it means third orbit radius. R3 equal to 52.9 picometers into 3 square by 3. 3 cancelled. So simply you will get answer. The answer is, so 158.7 picometers. 158.7 picometers. This is radius of third. So chance to ask number of questions, ratios also from this data. Just solve problems which are given in our material. Next, energy of electron. How to calculate energy of electron? Right. Second, energy of an electron. Generally, energy equal to kinetic energy plus potential energy, as you know that. Kinetic energy equal to half mv square, you know the formula. Potential energy equal to minus kZe square by r. Right? It is potential energy. Next, where mv square equal to, you know already, half kZe square by r is minus kZe square by r. So here mv square equal to kZe square by r. This is from radius of an orbit in the previous derivation we have taken. Then it is half, it is 1. So half minus 1 means minus half you will get finally. So then minus half kZe square by r. Clear it is? This is energy. Energy, total energy simply is total energy. Total energy. Total energy is equal to half into minus kZe square by r. Shall I take like that? This will be equal to potential energy. Half equal to minus kZe square by r equal to which one? Potential energy. That is total energy. Total energy is equal to half into potential energy. Simple problems are there. Next, total energy equal to this one. Half into minus kZe square by r. So this is nothing but mv square is a kinetic energy. Total energy is equal to minus half into kZe square by r. This is mv square. So simply this will be taken as total energy is equal to, this is nothing but, what is that? This will be equal to kinetic energy. So minus sign is there. This is kinetic energy. This is very, very good. Total energy is equal to minus, so this is 1, better we take it 1, it is 2, it is 3. It's very, very good formulas. Next, after this, total energy, we should know that is total energy formula we got is minus half into kZe square by r. You know r value, where r equal to n square h square by 4 pi square mv square 4 pi square mv square z k is mv square k into z is. So this is taken as, okay, it is first, it is 4. 4 will be substituted in 1. Then total energy is equal to minus half into, right? K Z E square by R will be this one. R means n square h square by, it will be shifted to again numerator into 4 pi square m e square k z, right? K is constant. Then the cancel is 2 2's or 4 times this. Then minus 2 pi square k z z into z z square e square into e square e to the power of 4 m it is k z square e to the power of 4 m over all the terms by n square z square. This is total energy. I gave you all the values for mass of electron, k value, energy, E means charge of electron, pi value, h value given in the previous derivation. So if you derived all these things, then finally you will get a value that minus 2.18. This one and this one will never change. It is depending upon the given data in the question itself. That is equal to total energy is equal to minus 2.18 into 10 to the power of minus 18 joule per atom into z square by n square. You just observe carefully. This is the formula for this. You know already. And first of all, formulas are important. Total energy is equal to half potential energy. Total energy equal to minus kinetic energy. These are all important. Next, if you changed all this, so look at this carefully. 1 joule equal to 10 to the power of minus 7, yes, 10 to the power of 7, yes. If you keep 10 to the power of 7 in place of joule, then you will get total energy is equal to minus 2.18 into 10 to the power of minus 11. So X per atom into z square by n square, right? So 1 electron volt is equal to 1.60. 1 electron volt equal to 6099 joules. 2.18 into 10 to the power of minus 18 joules equal to how many electron volts? Then if you solve this, you will get minus 13.6 electron volts. Clear this one? I am converting the joules into electron volts. Then total energy, this is another formula. Right. Total energy of an electron is equal to minus 13.6 electron volts per atom into z square by n square. This is another kind of formula in electron volts. Next, 1 electron volt is equal to 1 electron volt is equal to 23.06 kilocalories. Now, how many electron volts? 13.6 electron volts are equal to how many kilocalories? On solving this, you will get minus 313.6 kilocalories. 313.6 kilocalories. It means I am converting the electron volts into kilocalories. Then total energy of electron equal to minus 313.6 kilocalories. It is per mole actually, students. It is per mole. Kilocalories I have taken per mole, it is, remember, into per mole into z square by n square. This is in kilocalorie per mole of electrons total energy in a particular orbit, right? Next, formulas are very, very important. Total energy is equal to half into potential energy. Now, total energy is equal to half into potential energy. Potential energy is equal to 2 into total energy. 2 into minus 2.18, whatever you can take, otherwise minus 13.6, I am taking 13.6 electron volts per atom into z square by n square. This is potential energy of an electron in electron volts. In joules means minus 2.18. In kilocalories means minus 313 point. Understood already? Similarly, kinetic energy is equal to minus K. Kinetic energy is equal to total energy equal to minus K. Ke equal to minus total energy minus 13.6 electron volt per atom into what is that, Z square by N square. Clear? Minus into minus plus 13.6 electron volt per atom into Z square by N square. Clear? It is a very tricky and very important. Kilojoules per mole also you can consider. So total energy of it is kinetic energy, and this is potential energy. It is equal to minus 1312 kilojoule per mole into Z square by N square. Means they will expect answer in kilojoule per mole, joules per atom, electron volt per atom. Next one, kilocalories per atom, calories per atom, calories per mole, whatever the unit that is, they can expect. That's why follow all these formulas for which one. So follow all these formulas for energy of electron in different orbits. So this is about energy of electron and radius of orbit. In our next video, we will continue this topic.